Hi everyone, I am Rajitha, working as an Assistant Professor of Artificial Intelligence and Data Science Department in SNS College of Engineering. Today topic is inferential statistics. Let's move on to the subtopic, that is one-tail and two-tail testing. What is hypothesis testing? Hypothesis testing is a method used in statistics to make decisions based on data. It helps researchers and analysts decide whether the observed data provides enough evidence to support or reject a certain belief or claim about a population. A hypothesis is a statement about a population parameter like the mean or proportion. In testing, we usually have two types of hypothesis, the null hypothesis and the alternate hypothesis. The null hypothesis, often written as H0, is the default assumption that there is no effect or no difference. The alternative hypothesis, written as H1 or H0, is what we want to prove. For example, if a factory claimed that the average weight of its sugar packet is 1 kilogram, we can test this claim using samples data. If our sample shows a significant difference from 1 kilogram, we may reject the null hypothesis and accept the alternative. To test hypothesis, we use sample statistics, calculate test statistics like z-score or t-values, and compare them with critical values. We also calculate the p-value to determine the strength of our result. Hypothesis testing help in quality control, scientific research, business decision, and more. What is one-tail test? A one-tail test, also known as a one-sided test, it is a type of hypothesis test where the alternative hypothesis is concerned with deviations in only one direction. This means we are testing whether a value is significantly greater than or significantly less than a specified number, but not both. In a one-tail test, the rejection region is located entirely on one end of the probability distribution. For example, if a student claims that their average test score is more than 75, we are interested in whether the average is significantly greater than 75. This becomes a right tail test. Alternatively, if we want to test if the score is significantly less than 75, it becomes a left tail test. The one tail test allows us to detect an effect in a specific direction. It is useful when the research machines or claim is directional. The average is that it can be more powerful in detecting a specific effect, but the disadvantage is that it cannot detect effect in the opposite direction. If the actual result is in the unexpected direction, a one-tailed test might fail to detect it. What is a two-tailed test? A two-tailed test, also known as a two-sided test, is used when the alternative hypothesis is interested in detecting deviation in either direction, whether the value is significantly greater than or less than a certain number. In this test, the rejection region are located on both ends of the distribution. For example, if a company wants to test whether their product weight exactly 100 grams, any significant difference, either more than 100 grams or less than 100 grams, would be important. Here, the null hypothesis is that the mean weight is 100 grams and the alternative hypothesis is that is not equal to 100 grams. A two-tailed test is commonly used when we do not have a strong reason to expect the difference to be in one particular direction. It is considered more conservative and suitable for many scientific studies since the rejection area is split between two tails. The test is strict and require more evidence to reject the null hypothesis. A two-tailed test protects against unexpected result in either direction. And the difference between one tail and two tailed is the main difference between one tail and two tailed test lies in the direction of the test and how the rejection region is placed. In a one tail test, we only test for deviation in one direction, either greater or less than the claimed value. In contrast, a two tail test looks for any significant deviation in both directions. This means that the p-value in a two-tailed test is divided between the upper and lower tails, making it harder to reject the null hypothesis unless the evidence is strong. In a one-tailed test, all the significance level is concentrated on one side, making it more sensitive to detecting effects in that direction. Choice between the two depends on the research questions. If you expect a change in one only direction. Use a one-tailed test. If you are open to any change, use a two-tailed test. For example, if a new medicine is expected to increase recovery speed, a one-tailed test would be suitable. But if you are testing whether a medicine has any effect, positive or negative, or so two-tailed test is better. Misusing one um, tailed test can lead to incorrect conclusions, so the direction must be justified clearly. Hypothesis for both tests. Writing hypothesis is the first and most crucial step in hypothesis testing. For a one-tailed test, the null hypothesis usually state that a population parameter is equal to a specific value, while the alternative hypothesis state that it is either greater than or less than that value. For example, mu equal to 50 and mu is greater than 50. For a right tail test, um, mu less than 50 for a left tail test. In a two tail test, the null hypothesis remain the same, stating no difference or effect, but the alternative hypothesis changes mu is not equal to 50. This means we are looking for a significant difference in either direction. These hypotheses guide how we analyze the data and interpret the result. It is important to choose the correct form of hypothesis based on the research or business goal. Incorrect hypothesis can lead to incorrect testing and conclusion. The hypothesis also help in determining the rejection region and the p-value interpretation. Interpreting results with p-value and significance. Once we perform a hypothesis test, we calculate a p-value which tells us how likely our sample result is, assuming the null hypothesis is true. A small p-value indicates that the observed result is unlikely under the null hypothesis, and this gives us evidence to reject it. The significance level, often denoted by alpha, is the threshold for rejecting the null hypothesis. Common value for of alpha or 0.05, that is 5 percentage, or 0.01, that is 1 percentage. In a one tail test, we compare the p value to alpha on one side. If p value less than alpha, we reject the null hypothesis. In a two tail test, we divide alpha into two parts, and the p-value is doubled since we are checking both direction again. If p-value less than alpha, we reject the null hypothesis. If not, we fail to reject. It is important to note that failing to reject does not mean the null is true. It means there is not enough evidence against it. P-values and significance level provides a standard method for making decision in statistics. Choosing the right test. type, deciding whether to use a one tail or two tail test depending on the research objective. If the goal is to find whether something increases or decreasing, and you are only interested in that direction, a one tail test is suitable. For example, a diet program aiming to reduce weight would use a left tail test if the goal is to find whether there is any change regardless of direction. Then a two tail test is better. For example, testing if a new machine changes the average production time compared to the old machine would use to two tail test. Using a one tail test without a valid reason can lead to biased result. In many scientific fields, two tail tests are preferred because they provide a more balanced view. Always define your hypothesis before collecting or analyzing data. Do not decide the test direction after seeing the data, as this introduces bias. Choose your test based on the logical direction of the research question, not based on which test gives the result you want. And the real-time example is one-tail and two-tail tests are used in many real-life situations in medicine. One-tail tests are used to check if a drug improve health outcomes. Two-tail tests are used when testing if a drug has any effect, whether good or bad. In business, uh, one tail tests are used to see if a marketing campaign increases sales. Two-tailed tests help compare performance between two departments to see if one is significantly different from others. In education, one-tailed test might check if a new teaching method leads to higher score. Two-tailed test might examine if there is any difference in scores between two groups of students. Manufacturing companies use one-tail test to ensure that a defect rate does not exceed a limit, and two-tail test to ensure that the product meets exact specification. These tests help make decision based on evidence, reduce guesswork, and improve result. The correct use of hypothesis test increase reliability and help organization make smarter decision. And the final thought is one tail and two tail test are fundamental tools in statistical hypothesis testing. A one tail test is used when we are interested in detecting a difference in one specific direction. A two tail test is used when we are interested in detecting any difference regardless of direction. The choice of test affect how we calculate p-values and determine critical values. One-tailed tests have more power to detect effect in one direction but cannot detect changes in the opposite direction. But the two-tailed tests are more cautious and balanced, spreading the region area across both tiles. Hypothesis testing involved defining null and alternative hypothesis, choosing a significance level, collecting data, calculating the text statistics, and interpreting the result using p-values. Always choose the correct type of test based on your research questions. Misuse can lead to wrong conclusion. These tests are widely used in science, business, health, and industries to support data driven decision. Understanding when and how to use one tail and two tail test is a vital part of learning statistics and apply it responsibly. Thank you.